All right. So, oh, let me turn on the YouTube. Yep, YouTube is on. It's already starting to record. So, let me make a general announcement so that people know about this. Okay. I am. All right. So that is the announcement, and here is the link. I'm just doing this on the Discord side so you can't really see what I'm doing. But I do want to make sure that people have a link to the recorded video. There we go. Okay, excellent. Ah. All right. So what I want to talk about is how to implement the permutation program. So the challenge is, I have to uh, not give out the entire solution, but give people enough clues of how to do this, and also the basic mechanism, and more importantly, the way of looking at things when we are writing something that is recursive. Okay, so this is more a TGIF, special on programming concepts rather than mathematical concepts of CISP 440. Okay, so let me just go ahead and start with the really basic stuff. Okay, so I'm going to start with the basic stuff, which is how we deal with the concept of set. Okay, so I'm implementing everything in just plain C. I'm not going to use C++. That's just a personal preference. I personally do not use C++ unless there is a good reason to do it, because object-oriented programming, at least to me, is not efficient, and it is overly complicated for a lot of things. Okay, so we'll go ahead and just use regular C in this case. And so the first thing is, how do we deal with the concept of a set? Okay, I'll give you some ideas. I'm not going to finish the implementation over here, but the idea of using standard integer.h is so that we can use a fixed width integer, which is the nature of integers in C and C++ in most other programming languages, and we'll basically use 1 bit per item that we want to represent. So bit 0 is representing whether 0 is there or not. Bit 1 is representing whether 1 is there or not. Now obviously in our program we're supposed to use A to Z instead of 0 to 25, but the translation from A to Z, as in ASCII code, to 0 to 25 is pretty easy. It's just a subtraction of the ASCII code of A, from the character that will give you the integer, from 0 to 25. So that part is relatively easy. So the first thing we need to do is to implement a whole bunch of set operations. Now, it's not strictly required, okay, to have these set primitives. So having union, intersection, checking whether an element is in a set or not, adding an element into a set, initializing a set to be an empty set, and that sort of stuff. It's good to have, but if you're running short on time, you don't have to have these primitives, but it's good to start with those. Okay, but the focus of today's lecture is more about the nature of a recursive subroutine, and I want to kind of talk about how you can use a recursive subroutine so that each successive recursive call is going to plant a single character into a string, so that by the time you hit the very last one, it will give you the entire string. Okay, so I'm not gonna give you any code that you can use really quite literally and directly in your program, because that would kind of defeat the whole purpose of the programming of the homework assignment. But what I would do instead is to give you enough clues to get this done. Okay. All right. So let me also look at the man page of how we can get a random number. Let's see. Get random. So I'm just looking into the prototype of using a random number. Alright, so it's in standard lib and it returns a long int. Okay, so alright, so that is fine. Okay, so we'll pound include std_lib.h. So what I want to do is to write a function that basically constructs and print out a random string where each character of the string can be A to Z. Okay, so it doesn't check whether something has been used already. All it does is to say, I'm going to print out a string that is random up to a certain length. And we can also do this so that let me think about how to do this. We'll just do one string at a time first. Okay, so the entire function is going to print one string. The function is going to have a void return type. It does not actually need to return a value, and its name is random string, or print random string. Print random string, and it will need a few parameters. The first one it's going to need is an unsigned integer, which is the length of the string from the perspective of this invocation. Okay, so we'll just call it len, which is length. And then the second one is going to be a pointer to a character, because we need to keep track of where that string is beginning, and I really hate to use global variables, so it's going to be passed as a parameter. So this one is going to be a const. Let's see, can it be a const char? Yes. So we can make it a const char, and this is basically the string, the beginning of the string. Okay, so we'll just call str, which is the string, and then we'll give it one more parameter. Yeah, we'll need another parameter over here. So we'll give it, this one is just a char pointer without the const, because we are gonna have to change that location. Okay, or the invocations have to change this location. Okay, so we'll say where is my char? Okay, so I use this kind of obscure name for a reason. Okay, there we go. All right. So let me explain what each parameter is about. Okay, so to do that, let me use comments here. Okay, so length is the number of random characters in this string from this point on. Okay, so this so this point is really referring to this particular invocation of the subroutine. Okay, so from this invocation's perspective, how many more random characters is it responsible to generate? Okay, and then str is the points to the beginning of the entire random string. Okay, and then we have where is my char, points to the character that this point is responsible for. Okay, so between length and where is my char, it will basically, that really is the core of what we need to use in this recursive subroutine, is to know how many more characters do I need to generate and where's my position. Okay, so because it is a recursive subroutine, the first thing we need to do is to check for the terminating case, or the base case, if we want to borrow terminology from proof by induction. So now we say if length is 0, then we don't really have a single thing to do, because if length is 0, that means we have this whole string already. Okay, all the random characters are already initialized into the array. Okay, so the only thing for me to do is to terminate the string with a null terminator. Okay, so we'll say where, okay, star, where is my char is just going to be a 0. Okay, this is the null terminator. And then at this point, we are ready to print it to the screen. So put as, as a C function can do this. So when we print, we don't want to print where is my chart, because it's guaranteed a null string from um, where is my chart's perspective. So we're going to print it using str, which is from the beginning of the entire string. And that's it. This is what we need to do when length is 0. Otherwise, we still need to perform a recursive call. But before we perform that recursive call, I have to say, well, my char, okay, the character position that this invocation is responsible for is going to be based on a random number. And we cannot just say random, because that would give us a huge value. It is an unsigned, it's a signed long integer. So what we want to do is to mod it with 26. Okay, so that will give us a number from 0 to 25, and then we just have to add it to the ASCII code of lowercase a. So that will give us a lowercase a to lowercase z. And then what we do next is to call the subroutine recursively. So we say print random string, and this time length is decreased by 1. So I'm not changing the parameter itself. I don't need to. I just need to make sure that when I pass the parameter to the next invocation, it is 1 less than what it is now. Okay. str remains the same, because str is it points to the beginning of the entire string, and that does not change depending on which invocation in the recursion we are dealing with. And then where is my char needs to be added. We need to add 1 to it, because this position, the position of where is my char, is already filled in. Okay, I just did it. Okay, so the next invocation will now have to handle the next location in the string. Okay, so that's the recursive call. Okay, so now we can go to main. Okay, into main. And if I don't want to make this super duper fancy, I will just well, let's make it slightly fancy. Okay, because I do want to illustrate that it can handle multiple lengths. Okay, so we'll say if argc is greater than or equal to 2. Let's see, the first one is the path. So yeah, so we want it to be greater than or equal to 2. Then we'll go ahead and actually do something useful. Okay, we'll have a return 0 at the end here. And what we're doing in between, well, if argc is greater than or equal to 2, which means I have to put that into the parameter list of main. So we have unsigned argc, and then const char argv as an array. Okay, so in this case we can have an unsigned integer to store what the length is supposed to be. So we'll just say this is length, and it is atoi of argv1, because argv0 is always the path to the program itself, which is of no use in this context. But argv1 hopefully is a number. Okay, because there's no guarantee. Somebody might give me something that is invalid, but I'm not going to spend too much time to check for that. and then the rest of the program is just saying, oh, I need a string as well. So we'll go ahead and allocate a string of length. Okay. Um, so in this case, because I'm not using a string type in C++, so I cannot dynamically change the length of a string as needed. So that means I have to pre-allocate everything first. So we have a char array or pointer. So we call this char pointer um, this string. Okay, we'll call str. Okay. Um, and then we have to allocate, because at this point str is just an uninitialized pointer to a char, so we have to initialize it. And I'm going to use malloc here, or memory allocation. It's kind of the same thing as new in C and C++, except it is typeless. Okay, so I have to cast the return value of malloc, in this case to a char pointer, just so that the compiler does not complain about it. And it's going to be lem, or length plus 1, because we need one additional character for the null terminator. And every time you use malloc, it is a good idea to free the pointer, before the end, when you're done using whatever you just malloced. It's just kind of like new and delete. It's good to think about, this is where I do a new, this is where I allocate, and this is where I am going to free, delete to deallocate the object. So malloc and free are basically equivalent, somewhat equivalent to new and delete in C++. So in between, that's the only thing we need to do, is to print random string, and then we have to give it the original length, okay, which is what we interpreted from the command line. And then we have to give it the string, which is starting from the very beginning. So str passes to str as a parameter. And then where is my char is also str, because we have to start from the beginning of the entire string. So the first character position to get a random character is going to be the first char in the string that we have just allocated. Okay. So I think that should be it. The only thing it might complain about is malloc and ATOI, so I have to find out what header files are needed for malloc. Pretty sure that one is just standard library.c. So let's check that. Okay. Oops. Okay. Let me do that one more time. Man malloc. And then we just scroll back to the beginning, and it is using standard library.h. Okay, so that's good. And you can see how it is returning a void pointer, and a void pointer can automatically cast to a lot of things. Actually, I take it back. I cannot remember which way can be automatic, but it doesn't hurt to do a manual cast in this case. And then the other function I need to check is what was it again? ATOI, that's right. Okay, so ATOI, and I'm going to go back to the beginning. It's also in standard library.h, so I got both of them already done. Okay, excellent. So this program should compile and should run, assuming I did not make a stupid mistake somewhere, which I tend to do. Oh, okay, so this one doesn't like it because it put s needs to have its own header file include. So we'll look it up, and I think it's, yep, stdio is the one. Okay, so we'll go ahead and make that last change here. Pound include stdio.h, like so. Recompile the program, okay, and then we just run the program, okay, with a number. Okay, so if I want to print a string that has 3 random characters, this should do it. Yep. And this program is going to print out the same string over and over again, because the seed of the random number generator is the default in every single case. So it is the so-called randomness is very actually predictable with this program. Okay, if I want to generate like 25 characters, this is how we generate 25 characters, and so on. Okay, so let's go back to the source code of this program. Okay, and I hope you guys can see how this relates to your homework assignment. So even though what I do, okay, in the else case here is a very simple thing, I just make, one single random, assignment on this line, the line that the cursor is on right now, the mouse cursor is on. In your code, it simply is going like, okay, for this particular, so each invocation of the subroutine in your homework is representing a trial. Okay, so if you're down to a certain trial, then your job is really to, from the perspective of the subroutine, is to go through every single available choices to you for this particular invocation and say, well, this character is still available to me because it has not been used before. So I'm going to use this one, and then I'll call the subroutine recursively so that additional future, later, deeper, recursive calls will handle the additional trials, and then the very last one is going to print it out. So that is how, where your code is going to come in is what you do with the else portion here. But the key is there's no need to use true Cartesian products to keep track of every single permutation, because once we print the permutation, which is what would be equivalent to this line in this code here, we don't need to track it because the whole purpose of the program is to print all the permutations. We don't need to store all the permutations for some other applications. We just need to print them. So so that's why we just need to track a single permutation at any time of the execution of this program. When we finish the entire permutation, which means we have performed every single trial of the experiment, then we print out that particular experiment outcome, and then there's no need to keep that around anymore. So then we basically return from the from one invocation of your subroutine to the previous one. Then it will basically, that invocation will then ask, okay, so let's go through, let's see whether I have another choice that is applicable. It will have to kind of go through all the available letters from A to Z and then find out which one has not been used. What is the next one, I should say, that has not been used? Pick that one and then perform the recursive call again, and so on. Okay, so I'm hoping this is helping, okay, to kind of help you guys look at this homework assignment from a slightly different perspective. Instead of brute forcing using a true Cartesian product, you can just kind of track one single permutation, which is the one being constructed at this point. When it is done, okay, when it is completed, print it out, okay, and then just return. Okay, so each invocation is of the function is really just going through every single possible choice, pick up the ones that you can use, recursive call, come back again, pick the next one that you can use, call, recursive call again, and so on. So I am coining this type of programming invocation oriented programming, IOP, okay, which is well, I mean, it's an appropriate term for writing programs in a recursive way, is to look at each invocation and say, what am I supposed to do for this invocation? What is my job in this invocation? And what is the subtask that I can do by calling the subroutine recursively, because it really has the same nature as the problem that was given to me. Okay, so I call this invocation oriented programming, which is how we shift our perspective into writing program recursively. All right, so that is my TGIF special on a Friday. I hope you guys find it at least slightly useful. And if you have any questions, go ahead and ask the questions on Discord. I will try my best to answer those questions, especially if they are very specific questions. Okay, general questions like, if my program doesn't work, what should I do? I really cannot answer those questions very effectively. But on the other hand, if it's much more specific, I can try my best to help answer those questions. Cool. Okay, I'm going to stop the streaming here, and hopefully somebody is going to watch this.